Hey guys, before we get started, make sure you have your spiral out. You're taking these notes just like we normally would in class. I've already added this to my table of contents. It's part of Unit 6, but it's like a separate, it's not part of Laws of Exponents. It's its own little section in Unit 6. So we are simplifying polynomials. And remember, at any time you can pause it, rewind it, if I'm going too fast or writing too fast, so you can watch whatever you need. So the first question is, well, what's even a polynomial? We've talked about monomials, but we haven't really mentioned the word polynomials. So a polynomial is just considered a sum of monomials. Remember that sum means addition or subtraction. So we have several different categories we look at. We have the monomial that we have seen before. Monomial means there is one term. So we talked about terms at the beginning of the year. That would be like 4x to the 7th y. That's a pretty beefy term, but it is just one single piece. All that stuff is kind of connected. Well, a binomial, you guys are pretty smart. I feel like you can figure out that a binomial is two terms. So it would be like if I took my initial 4x to the 7th y and added 5y to it. There you can see, oh, there's one term, there's a second term. So when I talk about terms, that's what I'm kind of talking about. We also discuss trinomials, which we will do a lot of. Oh, not trinomials. Sorry, that's going to drive me insane. But that would be three terms. A triceratops has three horns. Trinomial has three terms. So if I take my initial one, there's my binomial, and then I subtract 3 at the end. There I have one term, two terms, three separate terms. Again, we're introducing kind of the addition and subtraction. If it has more than three terms, we don't go into like quadnomial or any of those. It's just a polynomial. It's many terms. So things to remember. Addition and subtraction are what actually separate terms. Okay, so I mean, there's not a whole lot of need to know that, but when I talk about different terms and counting terms, it's going to be helpful to know. Typically, not a big deal, but typically we write them in descending order. Descending order, meaning going down, like dropping. So the highest exponent down to the lowest. I'll give you an example of this. It's not as confusing as it may sound. Like, let's say we had 4x to the third plus 6x squared plus 5x. You're just putting like, oh, so cubed, then squared, then a plane of x. You're just making them go from highest to lowest. Again, not a big deal, but something definitely worth mentioning. Not vocab word that you might hear mentioned, and that's why I'm kind of doing a different star, is the degree of a polynomial. All that's referencing is the highest exponent. So for this little example that I would put there, its degree is actually a third degree polynomial. It also happens to be a trinomial because it has three terms, but the highest exponent also is a 3, so it's a third degree. Again, don't stress about knowing that. The leading coefficient is exactly what it sounds like. It is the first coefficient. So if you put them in descending order, then the leading coefficient is the first coefficient. These are vocab terms you're going to use more in Algebra 2 and maybe Pre-Cal. I'm just mentioning them here in case they do pop up so that you don't feel like I've never, ever mentioned them. So here's the difference in kind of what we've been doing and what we're doing now. We just spent a bunch of time working on exponent laws. And if I had 4x to the third times 5x to the third, this is one term times one term. That equals, here I use my exponent laws. So I multiply coefficients, do what the problem says. I multiply the coefficients to get 20. And when I've got exponents with matching bases, I add them together to get x to the 6th. The problem with kind of going back, because this next problem is not a new problem, but you're going to get it confused because now you've learned these other new rules for how to do this, is when we have 4x to the 3rd plus 5x to the 3rd. All of a sudden, now that you've learned these laws where you add exponents together, it's very tempting to want to add these 3's together. But in addition, you're just combining like terms. These are like terms. If you remember back to the beginning of the year when you first got a taste to like how bizarre my analogies are, we've got 4 3-headed dogs plus 5 more 3-headed dogs. So in addition, we've got to have 3-headed dogs and 3-headed dogs. Then I add them together to get 9. If I put them together, it's not changing, right? I still have 3-headed dogs. It doesn't change the label of my term. I'm really just adding the coefficients. This makes sense kind of with our exponent laws because coefficients always do what the problem says, right? So it's an addition problem. I'm going to add the coefficients. Exponents will not do the same thing that my coefficients did, so I'm not going to be adding the exponents. They actually just stay the same, okay? So if I mix it up a little bit, by the way, this is a binomial. There are 2 terms, just throwing that out there. If I change it just a teeny bit, 4x to the 3rd plus 5x to the 5th, can I combine them? I've got 3-headed dogs and 5-headed dogs. Yeah, no, we are very like judgmental in this capacity. We don't add these together. This is when you get that they are already simplified. And some of y'all were wanting to do this with the exponent laws. You were thinking, well, they don't match. It's x to the 3rd and x to the 5th. The tricky part is multiplication is not as strict as addition. Addition, they have to match. It's impossible. But multiplication, like here, they wouldn't have had to match. But am I making sense? They don't have to match for multiplication. Here they happen to. But for addition, they do. So remember, in addition and subtraction, they must be like terms. And that's old information. You can flip back to our notes at the beginning of the year. You've got tons of examples of the like term thing. So if I switch just a little bit and say 4x to the 3rd plus 5y to the 3rd, well, that one is also already simplified because even though they're both to the 3rd, that means that it's the same thing. Even though they're both to the 3rd, you've got, I don't know, 3-headed cats and 3-headed dogs, so you don't put them together. However, just so that we see a very clear difference between these, if I have 4x to the 3rd times 5y to the 3rd, you are allowed to multiply them together. So you multiply the coefficients to get 20, and then these I can't combine because they're 2 different letters. So I mean, it's kind of like combining like terms, but the variables or the variables still have to match. So in this case, you just have x to the 3rd, y to the 3rd. So you have 2 different sets of rules here. Multiplication, which means you can multiply anything, and addition, where they have to be the like terms, okay? So I'm just going to kind of write some quick notes on that. Adding and subtracting. So again, we are introducing plus and minus signs. You guys have not seen a plus or a minus sign in a while. When you are adding and subtracting, you go back to that whole rule of combining like terms. And then again, you only add and subtract coefficients. Because basically oh, y'all can't see that. I'm sorry. The concept is that addition and subtraction aren't powerful enough to change coefficients, okay? So if you want to kind of put a little note on there, they're not powerful enough. All right, I'm going to do a bunch of examples, but I'm actually going to do it as a separate video so that this one doesn't get to be too long. So watch the next video.